Hello everyone, today we are going to study about the units and dimensions. How to write dimensional formula for electrical quantities. First of all, we have to know what are the letters representing in dimensional formula. The first letter M means mass, and L means length, and T means time, and A means current. Okay, let's start our first example. Let us take voltage. We know that voltage is nothing but the potential difference. Potential difference means the work done to bring the unit charge from infinity to a particular point. So, voltage means nothing but work done on unit charge. Work done per unit charge. So, we all know that the work done W is equal to force into distance. We have studied about this in our intermediate. Okay, the force means mass into acceleration. So mass means the dimensional formula is m, and acceleration we know that acceleration means distance, that is displacement per unit time square. So displacement dimensional formula is length, that is L, and time dimensional formula is T, T whole square. So from this we get that the work done is equal to M L T whole square into distance, that is L. So from this work done dimension formula is ml square t power minus 2. Here the t is inverse. So work done is dimensional formula is ml square t power minus 2. So we put in this voltage, that is, we know that the voltage is work done per unit charge. Okay, here charge q. We know that the current means nothing but current is nothing but charge, number of charge particles moving through a particular point per unit time. So charge means here charge is equal to current into time. So we put this charge dimensional formula in this. So from this voltage V is equal to work done by charge per unit charge. That is, work done dimensional formula is ml square t power minus 2, and charge dimensional formula is I. From these, the voltage dimensional formula is ml square t power minus 3 I. This is the I. Here I we have to write A. A. Current in dimensional formula we have to represent in the letter A. So the dimensional formula for voltage V is m L square t power minus 3 and A inverse. This is the dimensional formula of voltage. So From this dimensional formula, we can derive some of the dimensional formula. Some of the dimensional formulas. Okay, we know that next dimensional formula we have to derive is resistance. We know that voltage is equal to current into resistance. From this, resistance is equal to voltage per current. So we know that the voltage dimensional formula we have derived here. That is ml square t power minus 3 a power minus 1 by current dimensional formula is A. From this, we can write the dimensional formula of resistance, that is m L square t power minus 3 a power minus 2. This is the dimensional formula of resistance. And next we can go to the dimensional formula of resistivity. Here resistivity, we know that the resistance is equal to rho L by A. Rho is resistivity, L means length, A means area of the conductor. So from this, resistivity rho is equal to R into area by length. So here we can write that the R dimensional formula we have derived here, that is resistance dimensional formula. We put the dimensional formula here, that is m L square t power minus 3 a power minus 2 into, we know that the dimensional formula of area A is L square by length dimensional formula is M. From this, the dimensional formula of resistivity, we can get that the ml cube t power minus 3 a power minus 2. This is the dimensional formula of resistivity. Now, another quantity can take, that is conductivity. Conductivity, we know that the conductivity is nothing but the reciprocal of resistivity. Conductivity is nothing but the reciprocal of resistivity. So from this, the conductivity dimensional formula is inverse of resistivity dimensional formula. From this, the conductivity sigma dimensional formula is m inverse L power minus 3 t cube a square. This is the dimensional formula of conductivity. Next, we go to the another basic quantity, that is power. Power, you know that the power is equal to voltage into current. We know that the voltage dimensional formula we have derived that m L square t power minus 3 a power minus 1. And the current dimensional formula is A. From this, the power dimensional formula is m L square t power minus 3 a power 0. So this is the dimensional formula of power. Next quantity we can take energy. Electrical energy. Electrical energy dimensional formula is nothing but the dimensional formula of work done. We know that the work done, we have derived that the work done dimensional formula is m L square T power minus 2. This is the dimensional formula of electrical energy. So we have get the dimensional formula of electrical energy. Next quantity we can take permittivity. Permittivity. For this, we have to know that the dimensional formula of capacitance. So capacitance. So capacitance. We know that the capacitance is C is equal to charge per voltage. Charge per voltage. So charge dimensional formula is A into T, and we know that voltage dimensional formula is mL square T power minus 3 A power minus 1. From this, the capacitance dimensional formula is M inverse L power minus 2 T power 4 and A power 2. This is the dimensional formula of capacitance. Okay, we get the dimensional formula of capacitance. Now we can find the dimensional formula of permittivity. We know that the capacitance C is equal to epsilon A by D. Epsilon is permittivity, A is area, and D is distance between the plates. So from this, epsilon is equal to capacitance into distance between the plates by area between the plates. So from this permittivity, the permittivity dimensional formula, that is capacitance dimensional formula into distance dimensional formula is L length, and area dimensional formula is L square. From this permittivity dimensional formula we can get, that is M inverse L power minus 3 next T power 4 A square. This is the dimensional formula of permittivity. Okay, next quantity we can take inductance. You can take the inductance. We know that voltage V is equal to L di by dt. From this, V is equal to Li by T. From this, L is equal to V into T by I. From this, we can get the dimensional formula of inductance. We know that the voltage dimensional formula is mL square T power minus 3 A power minus 1. Next, time dimensional formula is, we know that the time dimensional formula is T, and current dimensional formula is A. From this, we can get the dimensional formula of inductance, that is mL square T power minus 2 A power minus 2. This is the dimensional formula of inductance. Next quantity we can take electrical field intensity. Electric field intensity, that is E is equal to voltage per unit length. We know that the electric field intensity is equal to voltage per unit length. So We know the dimensional formula of voltage is mL square T power minus 3 A power minus 1, and length dimensional formula is L. From this, the dimensional formula of electric field intensity, we get that mL T power minus 3 A power minus 1. This is the dimensional formula of electric field intensity. Next, next quantity we can take permeability. Permeability. We know that the permeability, that is, we know that the inductance L is equal to mu n square A by L. We know that this formula. So from this, permeability mu is equal to L into inductance L into length L by n square into A. From this, we know that the inductance dimensional formula, that is mL square T power minus 2 A power minus 2 into length dimensional formula is L, and for turns there is no dimensional formula, and this is the area. For area, the dimensional formula is L square. From this, the permeability dimensional formula we can get at next T power minus 2 and A power minus 2. This is the dimensional formula of permeability. Permeability. Like this, we can derive all the electrical quantities, dimensional formulas. That's all for this section. And thank you for listening my video. Say no to plastic. Don't use the single-use plastic. Thank you.